Yo, what's going on guys? Tanmaya for Simple Snippets back with another video tutorial on aptitude problems. So in today's video tutorial, we are going to be talking and discussing about the topic on problems on height and distance. So we'll solve 5 different numericals on this topic, which is height and distance. And before we actually get into the problem solving, we'll first discuss a little bit of theory and some concepts and formulas that you need to know before we get on into this topic. Now also in the previous video tutorials, we discussed about train problems and time, distance and speed problems. So if you have missed those videos, you can check them out in this playlist itself, and I'll link those videos in the description of this video. So with that being said, let's get started. Okay, so as I mentioned that before we actually move on to the problem solving, let's first discuss a little bit about theory and some formulas that you need to know. So the problems on height and distance are pretty much related to geometry, and trigonometric concepts are being used in this case. So the first 6 points that you need to know are the trigonometric formulas and the trigonometric concepts. So as you can see on the screen, we have a right angle triangle. So this is the 90-degree angle. We are considering this angle as x, and say for example, this is the position where a person is standing and he is actually looking at point B. So this is the angle that he is making with the ground. So we have certain ratios, or we have certain trigonometric concepts and angles with their particular names, and depending upon the proper value, we have sine, cos, tan, cosec, sec and cot. So the formula to calculate sine of any angle, in this case we are calculating all these values for this angle x. So sine of x is given by perpendicular upon hypotenuse. So in a triangle, which is a right angle triangle, we have the base. You can see over here I've written it. It is also known as adjacent because it is right next to the angle. So it is just next to the angle. Then we have a perpendicular side, which is also known as opposite to the angle because you can see it is directly opposite to the angle that we are considering. And then we have the hypotenuse. So every right angle triangle has an hypotenuse. So the formula to calculate sine of this angle, sine of x, is perpendicular upon hypotenuse, which is AB upon OB. So this is the perpendicular AB and this is the hypotenuse OB. So this is the formula. Then we have cos, which is base upon hypotenuse, which is OA upon OB, and then we have tan of x, which is perpendicular upon base, which is going to be AB upon OA. Now the other three formulas can be directly derived from the first three. So we have cosec of x, which is 1 upon sine. So you just have to inverse these values. So sine is AB upon OB, so cosec would be OB upon AB. Similarly, sec is 1 upon cos and cot is 1 upon tan. So these are certain values that you basically need to by heart, or you just need to remember them because they are going to make your calculations much faster if you actually by heart them. There are different derivations for these formulas, and we are not going to talk about the entire derivations for each and every formulas or each and every ratios. So lastly, we also have three identities. So these are three equations which again have big derivations, which you can later on check out in your mathematics books, but right now we just need to remember them as it is. So the first one is sine square of x plus cos square of x is equal to 1. The second one is 1 plus tan square x is equal to sec square x. And the third one is 1 plus cot square x is equal to cosec square x. So yeah, again these three need to be by hearted, or you have to remember these, because if you don't, then it will be a little difficult and time consuming while solving the numericals. Now we also have certain predefined values at different angles. So if the angle is going to be 0 degree, then the sine of x is going to be 0. If the angle is going to be 30 degree, sine value is going to be 1 by 2. Sine 45 is going to be 1 by root 2. Sine 60 is going to be root 3 by 2. And sine 90 is going to be 1. So these are predefined values and they don't change. So it is essential that you actually go ahead and by heart it, because usually in questions these standard values are only asked, and these angles can also be represented in pi values. So 0 is 0, then 30 degrees pi by 6. Basically pi is 180 degree. So 180 upon 6 is going to be 30. Then we have pi by 4, which is 45. This is pi by 3, which is 60, and pi by 2 is 90. Pi value is usually 180. So yeah, we have these three values which you can remember, and then the other three would be dependent on them. So you can see sine is 0, 1 by 2, 1 upon root 2, root 3 by 2 and 1. Cos is exactly opposite. That is, you just have to write the sine values starting from 90 in opposite direction. So I have 1, which is over here. Then root 3 by 2 is over here. I have to write root 3 by 2 here. Then 1 by root 2 is same for both. Then 1 by 2 and 0. Now tan is usually depicted as sine upon cos. So if you take a division of these two, you'll get the values of tan. So 0 by 1 is 0. 1 upon 2 divided by root 3 by 2 is going to be 1 upon root 3. Then we have 1, then root 3, and 1 upon 0 is nd, which is not defined. Of course, we cannot divide any value by 0. So that is why we have not defined. Now again, cot is going to be reverse of tan. So since nd is over here, we have to write nd. Then we have root 3, we have root 3, 1, 1, 1 by root 3, 1 by root 3, and 0. Sec here is going to be inverse of sine and written in opposite direction. So we have 1. So 1 upon 1 is going to be 1. We have root 3 by 2. So inverse it and write it over here. So 2 by root 3. Then we have 1 upon root 2. We have root 2. We have 1 upon 2. We have 2 and 0. So 1 upon 0 is again going to be not defined. Similarly, cosec is again going to be inverse of cos and written in opposite direction. So we have not defined because we have 0 over here. So 1 upon 0 is going to be not defined. We have 1 by 2. So we have 1 upon 1 by 2, which is going to be 2. Then we have 1 upon root 2, which is root 2 over here. Then we have root 3 by 2, which is 2 by root 3. And we have 1. So you just need to by heart first three values, that is sine, cos and tan, and remaining can be calculated from these values itself just by reversing the order or taking inverse. In fact, basically you just need to remember these two values, sine and cos. Other four values can all be calculated. So these are certain points that you need to remember, and let's discuss last 2 points which come into picture when we actually go ahead and solve the problems on height and distance. So there are two concepts or points that you will come across when you solve these problems. We have angle of elevation and angle of depression. So suppose a man from a point O looks up at object P. So we have a person over here, he is at point O and he is looking up at some point P. Then the angle which the line of sight, so this is the line of sight, makes with the horizontal. So this is the horizontal line, or you can say the base, is called the angle of elevation. So this is the angle X, which is the angle of elevation since the man is looking at point P from point O. Similarly, we have angle of depression. Suppose a man from point O looks down at a point object P. So in this case, the person is standing over here. He is at point O. He is looking down at some point at P. So this is the line of sight in this case, and this is the angle of depression that he is making with the horizontal line. So in questions usually they mention that the angle of elevation is so and so. So you need to know what angle of elevation or angle of depression is. So this is what I wanted to talk about. So with that being said, let's start with the actual numericals now. We'll solve 5 different variations. So here's the question number 1. We have 2 ships are sailing in the sea on 2 sides of a lighthouse. So let's try to diagrammatically represent these values, or let's try to diagrammatically visualize this question. So we have a lighthouse. I'll just draw a lighthouse over here. So there are 2 ships sailing in the sea on 2 sides of the lighthouse. So this, let's say this is the sea, and there are 2 ships which are sailing on both the sides. So the angle of elevation of the top of the lighthouse is observed from the ship, which is 30 degree and 45 degree. So there are 2 ships A and B on both the sides. So this is ship 1 and ship 2. The angle of elevation from the ship to the top of the lighthouse is observed from both the ships, and one angle they're saying is 30 degree and another angle they're saying is 45 degree. Now they're saying that if the lighthouse is 100 meter high, so they're saying that this is 100 meters, which is this length exactly. The height of the lighthouse is 100 meters. The distance between the 2 ships is, so they're saying if the lighthouse is 100 meter high, what is the distance between the 2 ships? So we need to find out this distance. So let's consider this point as O, which is where the lighthouse starts from the ground. Now we have the angle of elevation, we have one side value, and you can see that ultimately this is creating right angle triangles on both the sides. So this is the reason why I represented it diagrammatically, because now you can visualize that there are 2 triangles on both sides of the lighthouse. You can see that both sides are having a 90 degree, and this is the 90 degree right angle which is being created. So now we can apply trigonometric values over here to calculate the distance. So let's start with the solution. Now the distance is going to be length of AO plus OB, that is this length plus this length, which is going to be the actual distance between the 2 ships. So let's first try to find out AO. So this is the triangle that we are talking about right now. We have the angle as 30 degree and this is 100 meters distance or length. Let's consider this top point as P. So we have PAO. So which trigonometric value would include this perpendicular and this base? Now we know tan of x is equal to perpendicular upon base. We just saw the point. So let me just show you if you want. So we have tan of any value or tan of any angle is equal to perpendicular upon base. So in this case, x is going to be this 30 degree. So we have tan of 30 is equal to perpendicular, which we know which is 100 meters. So I'll say 100 upon base. Now base in this case is going to be this AO value. So we have AO. Now we know tan 30 value. So let me just show you what tan 30 is. So we know tan of 30 is going to be 1 upon root 3. So 1 upon root 3 is equal to 100 upon AO. So ultimately AO is equal to 100 root 3. Okay, so we have one part of our answer. Now similarly, we can go ahead and try to find out the next part. So we found out this length, which is 100 root 3. Now we need to find out this length. So again, we can find out that by using the same method. So we have tan of 45 is equal to perpendicular upon base. But in this case, the angle is this. So the perpendicular is going to be same, but the base is going to be OB. So let me just show you what tan 45 is. So tan of 45 is going to be 1. So 1 is equal to the perpendicular is going to be PO, which is having the height of 100 meters. So we already know PO is 100 because it is the height of the lighthouse. Divided by the base is going to be OB. So just taking OB over here, we have OB is equal to 100. So we got the second part as well. So now we just need to find out the final answer. So the distance between the two ships is given by the total length of AB, which is this value, which is going to be AO plus OB, which is going to be 100 root 3 plus 100. Now I'll take 100 common over here. Then we have root 3 plus 1. So if you know the value of root 3, which is 1.73, so it would be 100 into 2.73. So the final answer is going to be 273 meters. So option C is our answer. So I hope you got question number 1, and the important part here is to actually visualize the question and use the appropriate trigonometric value to find what we need. So in this case, we used the trigonometric value of tan because we wanted to find out the base values in both the cases. So we had to use the tan value 2 times because we had 2 different angles and we only had one value, which is the perpendicular value, which is the height of the tower. So tan is the only ratio or only trigonometric value which included the angle, the perpendicular height, as well as the base. Okay, so let's move on to question number 2 now. So here's the question. The angle of elevation of a ladder leaning against a wall is 60 degree. And the foot of the ladder is 4.6 meter away from the wall. The length of the ladder is. Okay, so again, let's try to visualize the question. We have a wall over here and we have a ladder which is creating an angle with the base. So this is that ladder, okay? I know my drawing is not great. So we have a wall, we have a ladder, and it is leaning at the wall and the angle of elevation is given. So this is the angle. So the angle of elevation, you know, is the angle that is created with the horizontal base and with the top of any object or any place. So this is 60 degree that they are saying, and they are saying the ladder is 4.6 meter away from the wall. The foot of the ladder is this. So they are saying it is 4.6 meters away from the wall. So this length is 4.6. So what they are asking is length of the ladder. So they are asking this value. So again, you can see that this is creating a right angle triangle, this being the 90 degree angle. So let's try to name this. So I'll say ABC. So we know angle ABC here is 60 degree. We need to find out AB, which is question mark, and we have been given the value of BC, which is equal to 4.6 meters. So again, this is pretty simple now that we have visualized it. So let me just write down solution over here and we'll try to find out the value by using certain trigonometric value, because we know this is a right angle triangle and we can use the trigonometric ratios and values to actually find out the value. So in this case, we can use the trigonometric value of cos or cosine, which is cos of x is equal to base upon hypotenuse. So in this case, this is going to be the hypotenuse and this is the base. The angle x is 60 degree. So we have cos of 60 is equal to base, which is 4.6 upon hypotenuse, which we need to find out, which is AB. Now as I told you, you need to by heart the values of the standard angles and their trigonometric ratios. So let me just show you what cos 60 is. Cos of 60 is 1 by 2. So 1 by 2 is equal to 4.6 upon AB. So ultimately AB is equal to 4.6 into 2. So this will give us the final answer of 9.2, which is meters. So option D is our final answer. Pretty simple, right? So the only crux, as I told you, is to actually visualize this entire question in a diagrammatic form and try to use the trigonometric values which we have to find out the answer. Okay, so let's move on to the next question. Okay, so let me just read out the question number 3. An observer 1.6 meter tall is 20 root 3 meters away from a tower. The angle of elevation from his eye to the top of the tower is 30 degree. So the height of the tower is. So again, similar to question number 2, but with a slight variation. So let's try to visualize this. So we have an observer. He is standing on the ground, okay? So they're saying his height is 1.6 meters. So this height they're saying is 1.6 meters. And he is standing 2 root 3 meters away from a tower. So we have a tower over here. And the distance between him and the tower is 20 root 3. Now the angle of elevation from his eye to the top of the tower is 30 degree. So they are saying from this point, that is his eyes, to the top of the tower, the angle that is creating is 30 degree. But it is not with the base or the ground. So for his eye, this is going to be the horizontal line and not the actual ground. So this is what they have given us. And they are saying this angle is 30 degree and not from the ground. Now what they are asking is height of the tower. So they want to know this entire height. So let's try to first name all these points. So I'll say A, B, C, and let's try to name this point as D. So we already know that this value is 1.6 because you can see it is forming a perfect rectangle over here. So we know the height of the person is 1.6. So one side of the rectangle is 1.6. So the opposite side has to be the same. So we know this is 1.6 meters. Now we just need to find out this value over here, which is AC. So we need to find out AC, which is question mark. We already know this value because again we know the value of the base, that is the distance from the person to the tower is 20 root 3. So if this is 20 root 3, then this also has to be 20 root 3 because it is forming a perfect rectangle and opposite sides of a rectangle are equal. So we know BC, that is this point B, and C is 20 root 3. The angle X is 30 degree. So these are the different values given and we need to find out AC. So let's try to use certain trigonometric ratio to actually find out the value. So I'll say solution. So which trigonometric value has base and the perpendicular in its calculation? The ratio or the trigonometric value of tan of X, which is this angle, is going to be perpendicular upon base. So perpendicular value is AC in this case and the base value is BC, which is also equal to opposite upon adjacent. So the opposite value or the opposite side is going to be AC. The adjacent side for this angle is going to be BC. So X value here is 30 degrees. So we know tan of 30 degree, which is equal to AC, which we need to find out, and we already know BC, which is 20 root 3. So tan 30 is 1 upon root 3. We can see over here we have tan of 30 is 1 upon root 3. So 1 upon root 3 is equal to AC upon 20 root 3. So AC is equal to 1 upon root 3 into 20 root 3. So root 3 gets cancelled and AC is equal to 20. So we got our answer, but this is not exactly our final answer. So what we got is just this value, which is 20 meters. But what they are asking is this entire value, that is AD. So AD is equal to AC plus CD. Now we just found out AC, which is 20, plus CD we already know, which is 1.6. So the ultimate final answer AD is going to be 21.6. So this is our final answer and not AC, which is 20. So don't confuse that because you can see diagrammatically we've represented this and this will help you not get confused by the question. So option A is our answer. Okay, so let's move on to question number 4. Let me just read out the question number 4. From a point P on a level ground, the angle of elevation of the top tower is 30 degree. If the tower is 100 meter high, the distance from point P from the foot to the tower is. So again a pretty straightforward question based on which is similar to what we've been solving right now. So they're saying from a point P, which is at ground level, the angle of elevation of top tower is 30 degree. So we have a tower over here. So the angle of elevation is again 30 degree. They've given this tower is 100 meters high. So let me just write it down, 100 meters. The distance of point P from the foot of the tower is. So they are asking us this distance. So let me just name this imaginary right angle triangle that we have visualized from the question. So I'll say OPQ. So angle OPQ is equal to 30 degree. We have length of OQ equal to 100 meters and we need to find out PQ, which is equal to question mark. So let's move on to the solution. Now similar to the previous problem, we can say tan of X. So X is 30 degree. This angle is equal to opposite upon base or perpendicular upon adjacent, which is going to be OQ divided by PQ. So we already know tan of 30 is equal to OQ, which we know is 100, and PQ is what we need to find out. So tan 30, as you can see in point number 1, tan of 30 is 1 upon root 3. So 1 upon root 3 is equal to 100 upon PQ. So ultimately PQ is equal to 100 into root 3, which is going to be 100 into 1.73, which is going to be 173 meters. So this is our final answer. So option C would be the final answer. Okay, so let's move on to question number 5, and let me just read out the question. The angle of elevation of the sun when the length of the shadow of a tree root 3 times the height of the tree is. So reading out the question, we know that we need to find out the angle. So let's assume this angle as theta, which is equal to question mark, which we need to find out. What they're saying is the angle of elevation of the sun. So we have a sun over here. Let me just diagrammatically represent the question. Then we also have a tree, and the sun is casting a shadow on the ground. So what they are saying is the length of the shadow of the tree root 3 times the height of the tree. So if the height, which is this part, is equal to x, so the shadow that is being casted, which is this shadow part, is root 3 times of x. So as you can see, we are forming a right angle triangle with this being the 90-degree angle. So let me just name this imaginary triangle. I'll say ABC. And what they're saying is they want to find out the angle of elevation. So this is the angle of elevation we are talking about. And they've given us two sides which have certain relation with each other. So if the height of the tree is x, the shadow that is being casted is root 3x. And they want to find out this angle. So up until now in all the questions, we already had the angle which was given to us, and we had to find out the length of any one of the side of the right angle. But in this case, they've given us the side values in some relation, and they want to find out this angle. So let's start with the solution. Now again, in this question also we have to use a trigonometric value, but we need to find out which value to be used. So we need to use a trigonometric value which has these two sides, because these two sides we have some data related to these two sides. So we know tan theta is equal to opposite upon adjacent, which is also equal to perpendicular upon base. And in this case, since this is the theta angle we are talking about, the opposite value is going to be AC, which is AC, and the base is going to be BC. So this is exactly what we wanted, because we need to include these two sides. So tan theta is equal to AC upon BC. So we know AC here is x and BC is equal to root 3 of x. So I'll just write those down, x upon root 3 of x. So tan theta is equal to x upon root 3 of x. So just cancelling out the x values, we ultimately get tan theta is equal to 1 upon root 3. Okay, so we've reached at a point where we cannot further calculate anything, but we need to find out this angle and not any trigonometric value. So here we just need to apply a little bit of reverse engineering kind of concept, wherein we need to find out at what angle is tan value 1 upon root 3. So let's just go ahead and see the trigonometric table that we had in the point 1 which we discussed. So here is tan x, and we know tan of 30 is equal to 1 upon root 3. So now we can simply substitute that value in our question. So theta is equal to 30 degree, because tan of theta that gives value 1 upon root 3 is 30. So this is how we find out that angle. Okay, so that's it for this video, guys. I hope you understood all the different 5 problems that we solved, which are based on problem on height and distance. And the important part is to actually remember those ratios and trigonometric values, as well as the visual representation of every question. So once you draw the question out, you can easily find out the different sides and the angles that you need to find out, and it would simplify your problem solving. So if you like this video, give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel. Peace.